To measure the flow rate, we have a very popular flow rate sensor called the pneumotachograph. The principle is that sensing change in pressure across fixed resistance through which the gas flow is laminar can be used to calculate the flow rate. Basically, this is analogous to measuring current through resistance in electric circuits. For example, here, if you would like to measure the current, we basically we know the resistance, and if we know the voltage drop, we can actually compute the current as the voltage drop over the resistance. This is Ohm's law in electric circuits. This is exactly equivalent to having a pipe like this, where with a pressure drop of P1 minus P2 and the known flow resistance of R. And basically, when we know R, when we construct a sensor with a known laminar resistance, we can actually compute the flow as the difference between the two pressures. We have two pressure sensors, right? One here and one there across the laminar resistor. And basically, the difference between these two pressures over the laminar resistor will give us the flow. So basically, the tidal volume then can be computed by the integration of the flow rate over time. So the flow rate is like the current, and basically the volume is equivalent to the charge. So whenever we would like to compute the charge, we just integrate the current. Here we do that the same thing for the flow. We integrate the flow to compute the tidal volume. Tidal volume is the volume inspired or expired each breath. One advantage of this particular sensor is that it has bidirectional operation. So basically, we can detect flow going this way or going that way. So basically, we can use it to measure both inspiration and expiration tidal volume, which is unique to this particular sensor.